Welcome to our demonstration of the VIATRA Solver. Model-based systems engineering is widely used in the design of complex cyber-physical systems by using various modeling tools to catch design flaws early. This saves costs and automates the synthesis of different design artifacts, thus making the development process more productive. However, as any software, modeling tools are not free from errors. Software safety standards used for designing critical cyber-physical systems like DO-178C and avionics prescribe that only the output of a qualified tool can be trusted, and such a tool should meet the same requirements as the critical system component it designs. Since existing testing tools and real models of engineers are unable to detect all semantic corner cases in complex design tools, this makes tool qualification extremely costly. The automated and systematic testing of the modeling tools necessitates use of model generators to produce well-formed or intentionally malformed models as test inputs. In addition, such auto-generated graph models can be beneficial for database testing, system-level assurance for autonomous CPS, or design tool benchmarking scenarios. Automated generation of consistent models is a challenging task, which necessitates the use of complex logic solvers, graph algorithms, and tight tool integration with the underlying modeling environment. VIATRA Solver is a graph generation framework that can automatically derive consistent graphs with just one click of a button. We shall now demonstrate how the model generator is used, including its various inputs and outputs. First, the user can select the target domain or language. EMF is a popular modeling framework used by several industrial modeling environments, such as Yakindu and Papyrus. Our approach is able to natively support it. For our demonstration, we have selected state charts as our target domain. The metamodel, which is directly extracted from a third-party modeling environment, has a state chart object as its top-level element. This object contains a series of vertices, which can either be state or entry nodes connected via transitions. The modeling environment may also define other constraints on the metamodel. For this demonstration, we have defined 3 additional erroneous patterns using the declarative VIATRA query language. We constrain that each entry vertex cannot have an incoming transition and must have exactly one outgoing transition. Once the modeling environment is defined, we are ready to begin the model generation process. Users can select the artifacts contained in the modeling environment and configure a model generation process in an easy-to-use integrated editor. We define the desired model generation scope as 10 nodes, one of which is an entry node. We can also perform metamodel pruning using the keyword excluding. Notice that the VSConfig editor provides content assist to simplify the creation of a VSConfig file. We specify that we want 3 models to be generated. The generator supports several backend solvers, including Alloy, SMT, and VIATRA, and features an efficient graph solver algorithm. Once the configuration file is complete, we run the model generation by simply right-clicking on the configuration file in the Project Explorer and choosing the VIATRA Solver Execute. This generates an output folder within the project that contains the output models as XMI files, visualizations of the generated models, and some statistics about the generation. These generated models can also be visualized in 2 ways: using the graphical modeling language extension output or viewing the image representation of the models. Clicking on the corresponding format displays the visualization. The generated EMF instance models can also be opened by their native editor. To conclude, our model generator as a software tool is open source, EMF and VIATRA compliant, and utilizes multiple backend solvers, including a novel graph solver. Furthermore, it seamlessly integrates into the off-the-shelf Eclipse-based modeling environment, or can be run from the command line as a standalone jar. It is an efficient tool capable of scalable generation of diverse graph models with over 8,000 objects. Thanks for listening. If you're interested, here's a link to the tool repository as well as several related publications.